All right, look at example 2. We are given that EH is the perpendicular bisector. Okay, we're talking about this picture. So once again, I'm going to color it for you. EH is the perpendicular bisector. That's the perpendicular bisector of the picture. Now this is going to be just sort of common sense to you guys. Kayla, let me pick on you for 2 seconds. Look at that picture. Do you see how it's sort of like a kite or something? If this is the perpendicular bisector, the two sides of this kite should be equal to each other. So can you pick one piece and another piece and just name two pieces that should be equal to each other? GD and FG are going to be equal to each other. So let's use that. Okay? Well, for one thing, those two are just plain marked for us. Okay, so we can just go by the markings. All right? So can everybody agree that GD should equal GF? All right, but let's go ahead and use the expressions. What expressions are sitting right there? Right, GD, that's 10y minus 4, right? So 10y minus 4 should equal, what am I about to write, you guys? 7y plus 8. Everybody in this room knows how to solve this equation, am I right? Yeah. All right, solve it super fast. I'm going to give you a 5-second head start. All right, so you did minus 7y on both sides, yes? So you got 3y minus 4 is equal to 8. Then you added 4 to both sides like this. You got 3y is equal to 12. You divided by 3, and you got y equals 4. Okay, so we got that by setting this piece equal to this piece. Okay, so far so good. Let's see. Picked on Kayla. You know who I never call on? That guy, and that's why I don't remember your name right now. Tell me your name again. Matt. Matt, tell me another pair of things that would be congruent to each other.
HF and HD.
Let's see. HF and what?
HD.
And HD. Now that's true. But we don't actually have an expression on HD to use. So give me something else.
FE and DE.
Yeah, let's go ahead and do FE and DE. All right, let me circle it up for you to make it obvious. Okay, can everybody agree that FE should equal ED? All right, it just follows your common sense. The two halves of the picture. Rodney, what did you get for X, Rodney? I'm assuming you're already done. Oh, but you're not already done. Oh, I'm so disappointed. I need to call on you. It's my fault, Rodney. It's not your fault. I'm slipping. As a teacher, I have let you down. So, Rodney, can you see that these two parts would match?
I see it.
You see it? So what am I about to do with it?
Solve that.
How? What's the equation I'm about to write down?
7x plus 9 equals 9x.
True, true. Right, you set the equation and you solve it. Solve it as fast as you can.
Yeah,
Where do you write this whole stuff?
yeah, are we not doing anything in example 2?
Oh, yeah, we're just not there yet.
How did we skip that?
10 paciencia.
Wait, what number are we? Or 11?
We are on we're on example 2. We have not answered a single letter yet. But we need to do what we're doing before we can do that.
X equals 5.
Okay, so you agree with Bree.
They call me that at work, like the cheese.
Like the cheese. That's good stuff. So you guys got 9 equals 2x minus 1. Added 1 to both sides. 10 is equal to 2x. divided by 2. Yep. Everybody got x equals 5. Okay? Now, everybody has been telling me, but wait, Burton, when are you going to actually answer the questions? I hear you saying that y is 5, and I hear you saying that, x is 5 and y is 4. But that's not what they asked us. They asked us what's EF, DE, and all of this. Anybody know what I'm going to do?
No.
I'm going to plug it in, Cameron says, okay? Look, let's go back to EF, for example. Don't make me break out my highlighter again. Okay? Everybody look at EF. Okay? EF is right here in blue. What's the expression that we have for EF? 7x plus 9. So let's use that. EF, follow it with me. EF is 7x plus 9.
Are we just going to plug in X?
Yes, ma'am. So EF is 7x plus 9. But now we know what x is. What was x again, you guys?
5.
X was 5. So that makes 7 times 5 plus 9. So that's 35 plus 9. That's 44. So EF is 44. Okay, you just plug it in. That's all it is. Scott, look over here every now and then, brother. It makes me nervous when you look straight down the entire time like this, the whole class period. I feel like you're missing something. There's a lot going on the screen. I don't want you to miss it. Okay? Yes, Jamila.
Where'd you get the 5 from?
Here's where I got the 5 from. Let me scroll down. Okay. We got it from this. Would you agree that the 7x plus 9 should equal the 9x minus 1? Okay? Notice how both of these expressions involve x. But if I take those two expressions and set them equal to each other, then I get this. 7x plus 9 equals 9x minus 1. And then I just solved it, and I got x equals 5. That's where I got the x equals 5 from. So right at the beginning of this example, I set these two red pieces equal to each other, and I solved for y. I got 4 for y. And I set these two purple pieces equal to each other, and I solved for x, which turned out to be 5. For the rest of this problem, anytime I see a y, I'm going to plug in 4. Anytime I see an x, I'm going to plug in 5. Does that help? Okay. So we got 44 for EF. Now look, you guys. Fine, I got 44 for EF. When I go to do ED, do I need to do that all over again? Why not? This is 44. So guess what this is going to be?
44.
Right. Shouldn't ED also be 44? Because this is symmetric. If the left side is 44, the right side will also be 44. So I don't need to plug in 5 again. I could. Nothing wrong with it. But it's quicker just to realize, oh, this is 44, this will be 44. So ED should also be 44. So it's quicker if you do that. So DE should be 44. So look, there's one you don't have to show work on. Yay, you guys don't like to show work. Okay, what about FG? What is it? What expression do we have for FG? Is that the 7y plus 8? Yeah, FG is 7y plus 8. So let's use that. So FG is 7y plus 8. I forgot. What's y again, you guys? 4. So 7 times 4. It turns out to be 36. Why did I write it backwards? I don't know. I do. I'm a little dyslexic, I think. 36. Now, what other side should be 36? And do they ask us for it?
FG.
Okay.
Just kidding.
So this side is 36. which means GD should be 36. Did they ask us for that? Let's see. GD. Yeah, so this one should also be 36. You don't have to do it again. All right, let's see. What about FH? FH. Whoa, that's weird.
3x plus 4y.
That's right. Kiara says this one involves both variables. Okay, FH is this guy right here. Do you see it? All right, it's the 3x plus 4y. So let's do that. So we'll do 3x, all right, plus 4y. But x is 5 and y is 4.
15 plus 6.
15 plus 16, what's that?
31.
31. Okay, now be careful. Does that mean the next one's also going to be 31, you guys? No, we have to look at the picture and see what's what. Well, we found 31, that was FH. I'm sort of running out of colors. Let me do green. Alright, so here's FH in this green color. We just found that this was 31. Okay. Can you see something else that would be 31 that would match it?
HD.
HD would also be 31, wouldn't it? Okay, this would also be 31. Too bad they didn't ask us what HD was. Instead, they asked us what DF is. Can you see what they're asking us for?
Yeah.
Do I have any more colors, my friends? They're asking us for this, DF, the purple, all the way across. So how big is that going to be?
62.
That's going to be 62. It's got to be double. Double. Okay, so that one is 62. Why not? I'm going to use this giant marker. 62. Okay, are we done with this side of the page yet?
No.
Dios mío.